Hi, I'm Bob Dobkin. I'm the CTO at Linear Technology, and I want to talk about switching regulators, their losses, and their specs a little bit. First, I want to talk about the losses on switching regulators. Parameters that affect the losses are input voltage. As the input voltage goes up, the transition loss of the switches go up as they switch on and off. So higher input voltages give pretty much a change in your power loss. The next thing that we want to look at is output voltage. What is that? How does that affect our power loss? Output voltage doesn't affect the power loss very much, but it affects the efficiency a lot, and it can give misleading results when comparing different switching regulators, and we'll talk about that in a minute. The switching frequency, that can actually cause power loss to go up or down. As you increase the switching frequency, there's more transition losses in the switch, but also there's less magnetic change in the inductor, so there's less loss in the inductor for a higher frequency switching on the same circuit. So depending on the circuit itself and the components used, switching frequency can either cause an increase or a decrease in the power loss. And current. Everybody knows that current affects the losses. There's an I squared R loss in the switches as well as the inductor. So increasing the load current increases the losses. Power loss is a real world number. It's watts, and it's usable. Power loss is important in a couple of respects when you're using a switching regulator. It defines the size of the heat sink. Because you're losing power, you have to get rid of it to the air. It also sets up the quiescent current when you don't have any load on it. So at low loads, if the regulator is designed to operate, say, in burst mode, the power loss at low output currents is your drain on the battery, and it tells you how long your battery life is. So at both ends, power loss relates to your circuit and how it's being used and what effects it's going to have. And it's easy to understand. Power loss goes with the circuit. It's not manipulable very easily by changing some of the parameters, while efficiency is a function of output voltage. Unlike power loss, efficiency is a number by itself. It's dimensionless. It's the ratio of the output power to the input power, and that can be manipulated for a particular circuit. Efficiency is only good when you're comparing two identical regulators. They have to be the same input voltage, the same output voltage, and the same output current. Otherwise, the efficiency number is manipulated by the parameters of the circuit, and it doesn't really relate back to the circuitry that we're using. Power loss is the piece that is dependent upon the circuitry. Efficiency is dependent upon how that circuitry is set up. Just to give you an example, I calculated what the efficiency looks like as a function of output voltage if the power loss in a circuit stays constant. I set up a switching regulator. I set up the losses so that they're constant with input voltage, with output voltage, and with current, and I looked at what happens to the efficiency as we just change the output voltage. Here at low output voltages for the same power loss, the efficiency is down below 84%. As I raise the output voltage, the efficiency goes up toward 98%. I haven't changed the amount of loss in the circuit. By raising the output voltage, I've raised the amount of power that I get from the switching regulator, and by raising the power that I get from the switching regulator with a constant loss, the efficiency number goes up. So if you're comparing two switching regulators that have different input voltages, different output voltages, and you're looking at the efficiency, it's a misleading number because efficiency is modulated by the output voltage. This is a buck regulator, and I've got two curves next on this straightforward synchronous buck regulator. One is at a lower output voltage, one is at a higher output voltage. This curve is for 5 volts. This curve is for 3.3 volts. Now let's pick a point on these curves. This is the efficiency here. This is the power loss. If I look at 2 amps at a 24 volt input, I have 1 watt of power loss. If I go over to this circuit at 24 volts input and 2 amps, I also have 1 watt of power loss. And this power loss includes switching, inductor losses, everything. It's the total circuit being measured. But if I look at the efficiency at that point, here the efficiency is over 90%. Here the efficiency is under 90%. And the only difference between those circuits is the output voltage. One is 5 and one is 3.3. One other thing I want to talk about is at the low output power levels. A lot of our circuits have burst mode, which allow them to run with very low quiescent current if they're unloaded. And in this case here, at a load current of 100 microamps, the Q current goes way down. So these circuits that have burst mode, the power loss is the number you want to look at, because even though the efficiency is 25%, the power loss is the number you need to tell how long your battery is going to last. And of course, at the high end, the power loss tells you your heatsink size. Thank you. And for more information on switching regulators, go to www.linear.com.